Now we are going to learn about how to handle expensive computations in React. So let's say there is some expensive computation. So let's say there is a function power, and it does some computation. It's not that much expensive, but it might, you can might understand that any such function can be there which might take a little while to execute something and return the answer. If that is the case, then our intent should be that we should avoid calling it again and again unnecessarily. Whenever it is needed, whenever a new data is coming and the value is changing, then obviously we need to do that computation in spite of it being expensive, but unnecessary computation should not happen. So let's say right now the requirement is something like this, that yeah, there is a state variable data and that is initialized with this value, understand? So what is the purpose of this argument? So you understand, earlier we, let's say we use just 0, which means that this is the initial value. After it is initialized in the first render, the data is initialized with 0. After that, this 0 is never used. This 0 is never used, which means that after that, whenever we want to update the data, the only way to update it is to call set data with the new value, whatever you want to do. So from the second render, third render, and that those renders, because of n number of reasons, any state variable change, any props change, anything, whenever this re-renders, this thing 0 is never used. 0 is just used in the first render, that value is taken, assigned to data, and then done. Then this value is never used. But what if here some expensive thing is there? So for example, something like this, power props n. Now here what is happening is that in the first render, this whole value is computed and that is assigned to data, and you can see that that data is rendered here like this. So you can see that I'm printing props.n also, and value also. Okay, so you can see that 2 raised to the power 15, whatever is the value, that value is correctly coming here, right? Now the problem is that, let's say you change n. Firstly, let's say you change name. Okay, if you change name, then what is happening? Then this thing is re-rendering again, obviously, right? Because props is changing, so this whole component is re-rendering. But while it is re-rendering, then every time this thing is being recomputed again and again, even though this is not used. You understand what is the problem? This thing is computed, given to use state, but it is ignored because it is not the first render. Whenever it is the first render, then only that value is used. So this thing is being rerun unnecessarily. So you can see that, let's say I simply print here that this is expensive. Then you can see that, yeah, in the first render, obviously that thing will be called and it is needed definitely, but after that, even if I'm changing prop, then also you can see that every time this computation is being done, even though the value is not changing, this value is not changing, right? And obviously this value will not change because I'm not changing anything, but I'll change n also in a bit. But just to let you know that even if I'm simply changing props, which means that from here only the name is changing, which means that props dot name, this thing is changing, which means that the whole component has to re-render. But whenever this re-renders again, this thing is computed again and again and given to use state, just to ignore it, so why are we computing this again and again? So in order to avoid this sort of thing, if this thing is somewhat computational intensive, then there is a syntax where rather than passing a value, you can pass a function where the return value of that will be used. So for example, instead of this, you can use something like this. Okay, this is just a syntax, like set data has a functional style and normal value style. Similarly, in use state also, you can pass actual one value, or you can pass a function which will be called, and whatever the value is returned, that thing will be used as the initial state. Now you can see that in the first time it is expensive, that expensive render is happening, that is fine. But after that, even if I'm changing anything, all the props, the expensive computation is not done, because now it is part of the callback. If it is something like this, then it is not going to be re-rendered again and again. Sorry, it is going to be re-rendered again and again, but the value which is to be passed to use state, that value is not computed again and again, because now that is just a function, and that function is evaluated only the first time in the first render, not the next render onwards, second render onwards, right? And that's why this gives us a optimization. Okay, now the second thing is that what if I change n? You can see that if I change n, then this is becoming 16 and the value is not changing. Obviously the expensive computation is also not done, but at the same time you can see that the value is not changing, and this is expected, right? Because when this props.n, whatever the value, that value is changing, then this whole thing is re-rendering. That is fine, but we know that this state variable will only take the data from the initial render, whatever is passed here. Initial render, what is passed, that is like props 15, whatever the earlier value, first value props 15, that is passed, and now data is initialized. Data is initialized. Now the only way to change data is using set data. Even if this whole thing re-renders because of some other reason, either I change the prop or I change even the value itself using which this value was computed, but only the first value was responsible for initializing this data, and after that since set data is not called, and that's why this value, which is the data, which is that is never going to change. Okay, so this is obvious. Now let's say our requirement is that there is a computationally intensive value which takes some time, so we don't want to do it again and again, but the requirement is that that thing is being done only once, and after that it is never done, which means that we can cache its value. So whenever the caching of value comes into our mind, then we might think that yeah, use memo should be good, right? So let's try doing that, which means that we have something like this, that some data is there, but this data is just needed once. Okay, then I can use memo. Okay, and then we can have a functional style, and in that whatever the value is returned, that value, let's say, is the same value, this thing, and then what will be the dependency? Nothing, right? Only one time it has to be computed. Okay, but this depends on props.n, and we know that props.n is not going to change. Let's say that is given. Let's say that is given, that props.n is not going to change. Then or for that matter, let's simplify it. So let's say whatever, some 20 value is given, and this is fixed. This is fixed, this will not change, so there is no dependency error or nothing. Okay, so this is a computationally intensive task, and I just want to do it once, and whatever the value is there, that is cached and rendered. Okay, so that you can see that this power 20 value, or 2 to the power 20, whatever is there, that is calculated, and that is the data. Okay, now irrespective of whatever rendering happens, this computation never happens again, because we have cached the value. Okay, this value never is never used again. On the face of it, it looks fine, but there is a problem with it. Remember that in one of the earlier videos we said that use memo does not guarantee that it won't be run again. Use memo just says that it is a hint to the React that that this should be cached, but React is not guaranteeing us that it must be cached. It cannot be said that React. So we said that React might forget these values because of some, let's say, memory cleanup or something. They are trying to have some extra space by cleaning up some memory, and they can forget that, and when they need it again, they can again call back, which means that we can clearly see that it is not rerunning again, but maybe that once in a while they run it in some extreme situations. So this will work almost always, but if we want to guarantee that no matter what, this should never run again. This should only run once and exactly once. Then if that extreme is our requirement, then we should not use this. So in most of the cases this will work if that is not a big deal, even if it is called one a couple of more times. But the problem is that if we want to guarantee that it should run exactly once, then rather than this, even just this one is better. Why? Because I'll simply write whatever I want to do. Let's say prop power 20, that is what I want to cache, right? I will cache it, and I know that I never have to change it or anything again. So there is no need of set data, only this thing, right? So this is the better way to do it. But and now whatever you do, it will never change. And more importantly, even by mistake also this will not this will not be called again, because now we get guarantees that this will never be called again. They guarantees that use state things are just evaluated, the initial value is just evaluated once during the first render, and after that it never gets called. So if that much guarantee we need that this should be called exactly once, and why that guarantee is needed. So sometimes might be that rather than here you are returning some instance of some class or something, but you want just singleton instance of that, and after that you never want to change that. I'm just giving an example of power 20, right? But this can be anything here. So if that those sort of guarantees you need, then this would be the way to go. However, if those sort of guarantees you don't want, simply caching thing you want just to optimize the code, then this would be better way to go. Okay. However, we can achieve the same thing using refs also. If you remember that we have a syntax something like this, let's say const data is equal to use ref, and then we can let's say pass this thing. So right now I'm not memoizing it, but just I'll show you in a minute, and that I'll initialize it with this, and then after that dot current can be called. Okay, so what happens that when this thing is created, okay, then we essentially got this value initialized to this, and now we know that you can see that now we know that this expensive computation is done the first time, and after that whenever I change any name or anything, then also this is rerunning it. And why this is rerunning it? Because because uh, because this thing even though only the first time whatever the value you give, that is retained in data, that is retained, which means that even if let's say you have rather than here props dot n, let's say you are having, which means that whatever 15 you are passing, that thing is coming here, right? And after that if you change n, then you can see that this expensive computation is being done, but this value is not changing. This value is not changing because data.current is not changing. Why data.current is not changing? Because that is how useref works. Like use state, whenever the first time it is rendered, that data is taken, and after that you have to manually do set data or set state, then only it will change. Similarly in useref only, similarly in useref also, whenever the first render is happening, then this initial data is taken and that data is set into data.current. But after that if you want to change it, then you have to manually modify data.current, right? Simply re-rendering, it will re-render every time, but that will not change the data. So you can see that props.n is changing, but this thing is not changing because it is initialized with props.n when it was 15, and that will remain as it is until unless you change data.current. But the problem is that like this thing is evaluated being passed this when this line is executed, then at that execution of this line, this thing is evaluated and passed to useref, and since this is not a first render, so useref ignores it, but at least this is computed. And since this is computed, and that's why you can see that even though the value is not changing, data.current is not changing, but that expensive computation is done every time. So in order to solve for that problem, in use state we had this functional style of syntax, right? But in use ref we don't have that sort of syntax. We can't write something like this is wrong actually, right? So in use ref there is no such syntax. So what to do? What we can do is we can do a lazy evaluation. Okay, what does that mean? That means that I can start it with something like this. I can start it with let's say null, and then after that I can create a function, and that function can be something like get data, and it will give us the lazily evaluated cache data, which means that I will check that if my data dot current is null. If you remember that similar sort of thing we did one time earlier also, and the same thing we are doing here also, that if it is null, then only change data.current to this value. Okay, and then after that return this thing. Okay, so what is happening whenever you are calling get data for the first time, then it was null, and that time it will be evaluated, this thing will be evaluated, and data.current will be assigned that thing, and that thing will be returned. But when you call it second time, then data.current will be already that value, some value, it will not be null, and that's why this if statement will not be executed, directly the data will be executed, which means that we will not do that expensive computation again. As a result of that, this also works like memoization. So instead of data.current, if we simply call like this value we are rendering, okay, then we will see that when we do, then at the first render this get data is called, and we do the expensive computation, and we got the data.current. But after that, irrespective whether we change name or we change anything, this expensive computation is not being done, because that data is just whatever first time we have set it to data.current. After that we are not changing anything, and we are never calling it even again. Okay, so that will save us from additional expensive computation. So by now you might have understood that how to avoid expensive computation in order to make our code somewhat more optimized. So that will be all.